folks, 5.2. A couple ideas before we start. Hopefully you've seen this before. Let's say we have x squared. Remember, that's just a lazy way of writing x times x. Okay. So if we were to have x squared times x cubed, well, that's just saying x squared is just x times x, right? And isn't x cubed just a lazy way of saying x times x times x? How many of them are there? 5. Okay, so we've established the rule. X squared times x cubed is x to the 5th. So you're just adding them up. 2 plus 3 is 5. Okay. So be careful, because x squared cubed, this is different. This is a lazy way of saying x squared times x squared times x squared. So far, so good? X squared cubed. X squared, x squared, x squared. Okay. And isn't x squared just x times x? X squared is just x times x, and x squared is just x times x. How many of them are there? X to the 6. 6 of them. So if it's this situation, I multiply the 2 times 3 to get 6. And if they're just next to each other, then I add them up. So be very careful. See how there's no x for that? So make sure you're cool with this idea. Very important. Another idea that's important, let's say you have x to the 5th over x squared. X to the 5th is just x, 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 x. 5 of them, right? X squared is 2 of them. So if you cancel the x over x, you're left with 3 of them. X cubed. Oh, I subtract. Aha. Okay, this is making sense. And then the other way is, let's waste another piece of paper. Let's say you have x to the 3rd over x to the 7th. So very similar logic as to what we just did. So that's going to give us x to the 3rd is x, x, x. X to the 7th is 1, 7 of them, right? 1, 2, 3, 4. And you see how those cancel, and that leaves us with a 1 over x to the 4th. Okay. But if we follow the rule, right, we established a rule before that said if you have x to the 5th over x squared, you just go x to the 5 minus 2, which gives us x to the 3. Boom, aha. So what if we follow the rule here? Shouldn't this just be x to the thing on top minus thing on bottom, which is x to the negative 4? Oh, which is 1 over x to the 4th. Aha. So if you have x to the negative 4, that's just 1 over x to the positive 4. So if you buy that idea, let's say you have x to the negative 7, you can quickly just rewrite that as 1 over x to the positive 7. Okay, that's making sense. And now, if you're buying all this, what if you had, okay, tricky idea, 1 over x to the negative 5. The way I like to think of negative exponents is, you see how this is technically x to the minus 7 over 1? So all I would do is I relocate negative exponents. Oh, it's a negative exponent upstairs? Cool, I'm just going to bring it downstairs and make it positive. Okay. Oh, I have a negative exponent downstairs? Cool, I'll just bring it upstairs and make it positive. So you just relocate things. So wherever there's a negative exponent, so if it's upstairs, bring it downstairs. If it's downstairs, bring it upstairs. We always prefer to work with positive exponents as opposed to negative exponents for the most part. Okay, so there's your little lesson. Let us do some problems now. Again, just watch those videos. The Khan Academy and the Organic Tutor explain this in much better detail, but I thought it'd be fun if I rambled for 4 minutes. Okay, so we are now in 5.2. And let's see, let's take a look at 82. I don't know. Again, I feel like this is pretty straightforward, if what I just said a minute ago made sense. So A, x to the 4th times x squared. 4 of them, 2 of them, 6 of them. B, 8 to the 9x times 8 to the 3rd. Okay, so go back up to this one. Isn't always the bases are the same? So this is the base on bottom, and up top is the exponent. So base of x, exponent of 4, base of x, exponent of 2. And all we said was this was really x to the 4 plus 2, which gives us x to the 6. Okay, so if you have this weird mess, 8 to the 9x times 8 to the 3. Just follow the rules. Are the bases the same? Yeah, okay. And now let's just add the stuff in the sky. 9x plus 3. That's weird. Yeah, did you follow the rules? Yeah, well then you're done. Okay, cool. See. 3. God, my 3's are horrible. 3z to the 25. Yeah, this probably was a good problem to do. 5z to the 8th. Everything is just being multiplied. So there's a 3 and a 5 being multiplied. That gives me the 15. Z to the 25, z to the 8. Just add them together. Z to the 33. Z to the 33. 25 plus 8 is 33, I'm hoping. Okay. D, we have y times y cubed times y 5. Isn't y technically y to the 1? Sure. So now, there's 1, 3, 5. Just add them all up. Y to the 5 plus 3 plus 1. Y to the 9. Ta-da! Okay. Move on to number 90. Saving paper. 90. Let's see. Oh gosh, I can't see this. Need glasses. Zoom in. Okay. 90. Y to the 20 over y to the 10. So that's just y to the 20 minus 10, which is y to the 10. Soon you'll get good enough to just skip that middle step. You just look at it and you subtract it in your head. 90 part B. 7 to the 16 over 7, 2. So that's just 17 because the bases are the same. 16 minus 2, 7 to the 14. Hey, that looks weird. Yeah, who cares? Did we follow all the rules? Yes, we're done. See, maybe you throw it in your calculator, but I doubt it. 7 to the 14. Oh, on a side note, if you ever do have to throw that in your calculator, if you do something to a crazy power, there's a little button. I don't know if you can see it. It looks like it's pointing up, like that. That's called caret sometimes. So I would just go, I don't know if you can see this. I would just go 7, and then I'd hit that caret button, caret, 14, and then on mine I have to kind of slide over, hit enter. Yeah, it gives me some insane number. So the back of the book would probably have that. But just so you know how to do crazy exponents, you probably have a caret button. Or if you don't have a caret button on your calculator, you might have a button that says y to the x. So you can hit that also. So either a caret button or y to the x. I'm rambling. Okay, 90, C. T to the 10 over t to the 40. So that's going to be t to the 10 minus 40, which is t to the negative 30. We don't like negative exponents, so we usually say 1 over t to the positive 30. Catch that? T to the 10 over t to the 10 over t to the 40. Subtract them, you get t to the minus 30. And we don't like negative exponents, so we call it 1 over t to the positive 30. Okay, so D, 8 to the 3rd. My 3's are horrible, over 8 to the 5th. 8 to the 3 minus 5 is just 8 to the negative 2. See how I did it in my head right there? Which is 1 over 8 squared. And 8 squared is pretty manageable, so I just call it maybe 1 over 64. R. Okay. Oh. I'm not sure if I mentioned this. Let's just do 94. Whoa. 1 second. Losing track of things. Okay. 94. 94. 13 to the 0. Did I mention that anything to the 0 is 1? And then the next one, that's part A. B, k to the 0 is 1. We're going to assume k is not 0. On a side note, 0 to the 0 is undefined. Some things in math are complicated. So you just have to believe me. 0 to the 0 power is undefined. If you'd like an explanation, email me. But for right now, just buy it. Okay. 98. It says simplify each expression. So part A, it says b to the negative 4. Okay, so it's b to the negative 4, so we just move it downstairs, make it 1 over b to the positive 4. Okay. Part B, 10 to the negative 2, so just make that 1 over 10 to the positive 2. Easy peasy. 98C, 1 over b to the negative 3. Oh, it's negative downstairs, bring it upstairs, b to the positive 3. And question D, 1 over 5 to the negative 2. It's downstairs, bring it upstairs, make it 5 to the positive 2, which cleans up to 25. So you clean it up if the numbers are manageable. Oh, fractions. Oof, 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 oof. Okay. 102 is good. Pay attention to this one. 102. 3 over 10 to the negative 2. Couple ways you can do this. So here's one way. The negative 2 is talking to each of them, so you might say, oh, that's 3 to the negative 2 over 10 to the negative 2. Cool. And if it's 3 to the negative 2 upstairs, doesn't it become 3 to the positive 2 downstairs? And if it's 10 to the negative 2 downstairs, doesn't it become 10 to the positive 2 upstairs, which gives us 100 over 9. Aha! Now, here's a trick. So that's a good way to go. It's a good approach. If you're fancy like me, a trick is you say, oh, it's a fraction to the negative 2, so I just flip everyone over. So I might say that 3 over 10 to the negative 2 is just 10 over 3 to the positive 2. And then I would just say, oh, that's 10 squared over 3 squared. Too fancy? Okay, my bad. But basically, with that negative 2, you saw how I could just flip it? So, oh, negative 2, I prefer if it was positive 2. Flip it. You don't like that? Okay, just do it that way. 112. How long is this video? 12 minutes. Okay, that's not too bad. So far. A. Let's make sure. 112. A. Y to the 5th times y to the negative 5th. So in this situation, don't we just add them together? Isn't that just going to be y to the 5 plus negative 5, which is y to the 0? And didn't we agree earlier that anything to the 0 is 1? Yes? Good. B. PQ negative 4. P minus 6, Q minus 3. Okay, so there's no exponent outside the parentheses, so you could just rewrite it as P times Q to the minus 4, P to the minus 6, Q to the minus 3. I see a P to the, put a little 1 there, make you happy. P to the 1, P to the minus 6, add them together, that's P to the minus 5. Q to the minus 4, Q to the minus 3, add them together, that's Q to the minus 7. And then, remember, we don't leave negative exponents, bad manners. P to the minus 5, that's technically upstairs, so let's just bring it downstairs. Q to the minus 7 is technically upstairs, let's bring it downstairs and make it Q to the positive 7. And what goes upstairs? It's not just nothing, got to put a 1. Aha, it's all making sense. And question C. What do we have for C? Negative 5, M, 4, N, 6, 8, M, negative 5, N, negative 3. Okay, negative 5 and 8, that's going to give me negative 40 when I multiply. M4, M minus 5, add them together, that's M minus 1, N6, N minus 3, 6 and minus 3, give me a 3. Okay, so negative 40 is just sitting there. There's a top and a bottom. M to the minus 1, why don't we bring it downstairs and make it M to the positive 1? You don't need to put a little 1 there, but you could if you want. and n to the positive 3, so we just leave it there. Ponder this one. Make sure that one made sense. That one actually got a little interesting there. 116. Let's just jump to 120. We can handle that. 120. World's longest video. 120. Okay, 120. Negative 4ab quantity squared. The little 2 is talking to everybody. See? Negative 4 is getting squared, a is getting squared, b is getting squared. What's negative 4 squared? Negative 4 times negative 4 is positive 16. A squared, b squared. Cool. Next one. 5x to the 0. Anything to the 0 is 1. C. 4y cubed all to the negative 3. Okay, let's see what we got. 4, so if I distribute this little negative 3 goes to each of them. So 4 to the negative 3, y to the multiply negative 9. Okay. And now, these are all technically upstairs, so let me move them downstairs. 4 cubed, y to the 9th. And upstairs, y to the 9th. And upstairs is technically not nothing, there's a 1. So that's going to be 1 over 4 cubed is 4 times 4 times 4, 64, y to the 9th. Aha. Make sure you're cool with that one. 120d. Negative 7y, negative 3, all to the 2. Okay, so negative 7 is getting squared. Negative 7 times negative 7 is 49. And y to the negative 3, so multiply that. Y to the negative 6. 49 is just sitting there. Okay. And y to the negative 6 upstairs comes downstairs, becomes y to the positive 6. Aha. Okay. Let us try. That was 120. 124. 124, 126. 124. They're all the same. X over 3 to the 4th. That little 4 is talking to everybody. So x to the 4 over 3 to the 4. X to the 4, calculator, 81. 3 times 3 times 3 times 3. Or use a little caret. 3 caret 4, or y to the x button. See if you get 81 using your fancy calculator. B. A over b to the minus 5. Okay, I'll show you my fancy trick in a second, but you may say that's a to the minus 5 over b to the minus 5, which becomes, so a to the minus 5 upstairs becomes a to the positive 5 downstairs, b to the minus 5 downstairs becomes b to the positive 5 upstairs. That works. Or I might have said, oh, there's a negative exponent. This might be too fancy. Feel free to ignore me. Let me flip that over. So this just becomes b over a to the positive 5. What? Which is just b to the 5th over a to the 5th. Same. Okay. C. Oof. 2x squared y cubed all over z squared, all quantity squared. C. 124c. 2x squared y cubed all over z squared, quantity squared. Okay, so the little 2 here is talking to everybody. It's talking to the 2, to the x squared, to the y cubed, and the z squared. So 2 squared is 4, x squared, so 2 times 2 is 4, y cubed squared, 3 times 2 is 6, aha, and z squared squared, z to the 4th. Ta-da! Cool. So, yep, you should be able to handle 5.2 now.